In the second section of chapter 5, we are going to discuss inheritance. First, we have to understand what is inheritance and then how to do overriding and overloading. And I'm going to show you some of the examples. There's a concept called shadowing, and that means you're hiding a portion of the base class functionalities to the derived class. That is the way that we do encapsulation. We've got a couple of keywords. One is MyBase, the other one is MyClass, that I'm going to go and talk about it. Inheritance concept is when you have a class and you want to use an existing class within another class. You're inherited from it. In other words, you're going to take advantage of some of the functions, properties, and methods of one class already. You don't have to redefine them again. So the derived class inherits from the base class. The properties, methods, data members, events, and event handlers can be inherited depending on the scope. For the sake of discussion, if I jump here to my Visual Studio, I've already created a public class human. If I just go ahead and say public class C child, and if I say inherits, of course I misspelled, if I say inherits from C human, automatically you see that it's going to pop up with a IntelliSense menu and I can choose from the available classes. If I say just inherits from C human and don't implement anything else to it, all I have to do, come down in here and try to instantiate an object from it. Now if I go with C child, despite the fact I didn't have anything, I automatically inherit all the functions, methods, and properties of the base class. So what's the advantage of this anyways? I could have just directly go with the C human. The catch here is that not necessarily you want to have just a C human. I can have my own function. For example, I can say my child function, and then you can realize that from the client application, by the time you're creating an instance of that particular class, you're not only getting all the functions of the base class, but also you get whatever you have in the child or derived class. So this is an advantage of inheritance. Just for the sake of discussion, show something, it still works the same way. I didn't have to do anything. That's the first concept of reusability. So I define it only one time, and other programmers from any other locations can actually take advantage of that. These are the beauty of inheritance concepts. So the keywords that we can use is like inherits, as I showed you. You could say inherits from the base class. Usually we use these keywords within the derived class. You could say not inheritable. That means it cannot be inherited from. That means you make sure no one can inherit from you. You just want to close it right there. No one can inherit from you. That's it. Or you could say must inherit. Means they cannot create an instance of it directly. They have to inherit from it first. Usually we use that keyword only for base classes. And then you could say protected, which allows only and only derived class to use it. No one else can use it. There are some examples I'm going to show you right now. Let's go ahead and clean it up. Let's go and create a new item. I'm adding a new class. Let's call this classes. I'm just going to name it classes, because within that I'm just going to go with my base class. And here, part of keywords, I can say must inherit or not inheritable. It's totally up to you. I can go with must inherit. If I go with that, no one can ever instantiate any object from this. So for the sake of discussion, if I go and say sub new, I'm going to create a constructor. Message box, I go with constructor of the base class. Now, from in here, if I wanted to take advantage of this, I'm going to put a button in here, and I'm going to just say create an instance of base. And I'm going to put the code in here. I'm going to say them, for example, an object as new base class. What did I call it here? Under classes, I call it class called base. So obviously, part of my namespace, I call my classes dot base. That would be, let me find out where is the classes. Obviously, I can't even see the base because I said must inherit. That's the whole idea. If I go ahead and get rid of it, then you realize that it would be available. Base. So as you see, if I say must inherit, you won't be able to even see it in an IntelliSense. It just fails on you. You see right now is okay.
It almost sounds like an opposite when you say must inherit.
No, it says must inherit. That means someone has to inherit from it. Versus just a regular class. You say this class must be inherited. The keyword that they use.
Must have been.
Right.
Okay.
Just the keyword. I know what you're talking about. The keyword, yeah,
Literally, when you say
is weakly designed.
you must inherit. That's the way I
Right.
understood it.
Yeah.
But
I understand.
Says,
Right.
it must have been inherited.
Must have been inherited. That would be a
Okay.
better keyword, But
Right.
it says must inherit means someone has to inherit from it. You can interpret it in many different ways.
Yeah. Okay.
But anyhow, that's what it means. And it says new cannot be used because it declared as must inherit. You see that?
Yeah.
So I just wanted to demonstrate that for you. All right. So now if I go down in here and say public class derived, okay, and I can say inherits, right, base, which is my class right over here, then within this form, even though I want to create the base class, I don't have to say base, I can say derived. I'm going to be fine. Because this derived really goes and creates an instance of base anyways. So despite the fact, within the base, if I go and declare some function, like for example, say hi, now here within my form, if I go down in here and say an object dot say hi, it really does work that way. So if I go and run this, you realize that by clicking on that button, let me see what is the problem over here. Of course, I made a mistake. Part of the previous demonstration. Now, meanwhile, I'm waiting for this form to get started. If I create an instance of a base, first says construct of a base class, despite the fact I'm driving it from derived, and then it says hi. So just wanted to show you that using must inherit enforces you to not be able to create an instance of this class. You have to derive from it. You have to inherit from this and then use it. So despite the fact I used base over here, it shouldn't be base, it should be derived. Because I couldn't even create an instance of a base because it says must inherit. Usually that's the way we do it. You don't have to specify must inherit. You do that when you don't want people to create an instance of it directly. You can protect it that way. Then you have protected keyword. The protected keyword limits the access of a property, method, and data member to only the derived class. No one else can take advantage of it. Only the derived class can. You can actually do it on a, for example, procedure level. Let's take a look at this. You see, in this scenario, my derived class, I'm going to have a protected sub only for children. Message box only for children. Now, if I go and create another class, public class, second generation derived class, and I can say inherits of derived class. Let's go actually and take a look at this. This is my derived. There we go. I'm inheriting from that. And here, part of the form, as you see, I go with second gen derived class. If I just go ahead and repeat the same code over here, first of all, as you realize, an object is not showing the only for children, does it? Part of the IntelliSense. Versus if I just copy paste the same code in here, however, instead of the derived class, I go with second generation derived class, then an object, it says, actually, let me see, what did I do wrong? Because part of classes, I have said protected sub. And when we say protected, we should limit the access of a property method or data member, event or event handler to the defining class of any derived class based on the base class. Well, obviously, this has become my base class now. So I should be able to take advantage of this in a better way. Let me see. Let's go with a friend rather. If I go down in here again. There we go. Then you see only for children. If you say protected, only that class alone can use it. If you go with friend, only that class and whoever is part of the derived class can get it. So right now, if I go down in here again, an object, you see, friend means both of them. Versus private, if I go and make that a private now, and try to see this from the derived class itself, an object dot, you see, you won't be able to see that anymore. You won't be able to see that here either. So private and protected really protects for that particular class alone. So once again, inherits from the base class, not inheritable, cannot be inherited from. You can, enforce inheritance not to be applied. Must inherit instances of a class cannot be created. Must be inherited from a base class. Make sure that you're inheriting. And then finally, protected member scope that allows user only by driving classes. Overriding and overloading would be the second section. Drive classes can override any inherited property or method. For the sake of discussion, if you have any functions over here, you can override it. For the sake of discussion, on the base class, I have say hi. So in here, you can't just go and say sub say hi because it's going to fail on you. It says you're inheriting a function within the same name. So what do you want to do? Do you want to override it or do you want to overload it? The concept of overloading requires you to have the same exact signature with a different, argument listing. So when a drive class which inherits from a base class, it inherits all available functions and methods, obviously. So sometimes you may want to change the behavior of some of these functionalities. You can do the overloading or do the overriding. Overriding, it allows you to go and override it by putting the overrides keyword. If you go overrides keyword, you have to actually specify this keyword before the sub. And then here, part of the specific sub procedure, as you see, it says say hi overrides a sub in a base class base that is not declared as overridable. Means this is a good syntax, but you're not allowed to do it because this sub has not allowed you to do override it. So if you want to do that, you have to say overridable. And in order to do this, all you have to say here, say override the ball. Means you allow to be overridden here, and then you can say overrides. You're going to be fine that way. So there are two places that you have to do this. Number one, you have to allow override to happen on your drive classes by putting the overridable keywords in here. You say, okay, this is overridable. You can override it. And then you can here say, hey, I'm overriding this. And then you could put your own message boxes. I can say message box overrided say hi from the drive class. So this way you're overriding. So to create your own special implementation of a drive class, you have to specify overridable keyword in a base class, and then you could simply go ahead and override it in a drive class. Sometimes you want to enforce a function to be overridden. You can say must override versus overridable. If you say overridable is optional, but you say must override, means I don't have any implementation. You got to do it on your way. So you say you must override it if you want to inherit from me. You must override few functions, like initialization. Then you have overrides keyword as I showed you, and then finally not overridable means, you know what, you cannot override it. The concept of overloading is to create a method in a drive class that overload a method defined in a base class using overload. So overloading gives you the capability in order to use the same function name more than once, rather than changing the implementation of it. You see the difference between overriding and overloading is, overriding, you are just changing the implementation. Overloading, you use the same function name in a different way. So that's a little bit different. We were talking about overloading before, in the first section of chapter 5. So just all you have to do, use the overload keyword and you're going to be fine. For this example, I've already overridden the say hi. Now what I want to do, I can say sub, but before that I'm going to say, I'm going to overload sub say hi. You see, now it says, hey, sub say hi must be declared overloads because another say hi is declared overloads. So I say I'm overriding and overloads sub say hi. You see, you cannot use both of them at the same time. It says you have to have a different signature now. If I do this, I can say, for example, x as integer. Because if you go with overloading, you have to have a different signature now. In this scenario, I just had to do the overloads just because I'm using overloads more than once. In other words, once again, not to make it confusing, inside of the base class, I have a function. In order to make it to be overrided or overloaded, I have to specify that, overridable. If I wanted to use the same function exactly the same way, but with different implementation, I use overrides keyword. If I want to use the same function with a different signature, like I want to pass parameters to it, I have to use overload. If I want to use both of them, means I want to have overriding and overloading at the same time, then I have to combine the keywords. And for the second overload, I have to change the signature. Is that clear? In this scenario, this overload refers to this guy. This override refers to the base. So let's see all these things in action. In this scenario, if I say dem a as new, my classes that, let's go with drive. As you see, I have a new construct if I want to. However, if I don't do anything, a dot, I have say hi. And the say hi, I have two implementation of it. One with and one without implementation. Let's go with say hi and then say hi. So not only I'm overloading it, but also I'm overriding it. Now, once again, let's go back to this. As you see, the say hi over here, just say message box. Let's put a breakpoint on a base, see if ever is going to be called. So if I click on a button, instead of this button, constructor of the base class is going to happen, which is right here. And then it says overrided say hi method. It never went to this breakpoint just because you overrided it in here. Since I didn't have any message for the overload function, let's go ahead and terminate this application. Do it twice. I'll go with x.toString. Don't forget, anytime you wanted to show an integer into a message box, you have to convert it into a string. So I'm launching the program one more time.
To show it an integer on a message box, you have to convert it?
You have to convert it to a string. That's right. So constructor of a base class, say hi. You see that? Automatically goes through the whole overrided and overloaded functionality. But it never stops here, ever. Once again, let's review some of the examples. This is an inheritance example. I have a base class which has a couple of methods. One called override method, one called other method. In order to make the override method overridable, I have to specify the overridable keyword. So in this scenario, if I want to take a look at the derived class, first I have to use inherits keyword in order to inherit from the base class. And then for the function I need to override, I use the public overrides keyword. And I use my own way of implementation. If it happens that in a client application you want to take advantage of it and use it, which is the last section of this slide, you're creating an instance of that class, and then you call the methods accordingly. And instead of showing the base class, you're using the derived method because you have overridden it. There's a technique called shadowing. Using the shadowing, when a derived class inherits from a base class, it can either override a method or shadow it. You know, sometimes you don't want to override it, but you just don't want to show it either. Overriding replaces the existing method based on the method name and a signature. Shadowing effectively hides the method in a base class and only shows the derived class method. So you don't have to be worried about it. In this scenario, as you see, the base class has a sub-procedure called M1. It's not overridable by default. And then you have a class called a shadowed. You're inheriting from the base class, and you say public shadow sub M1, and you're implementing your own method. As you see, if you go with no argument parameters to the M1, it's going to generate an error because you don't have any function. You have shadowed it. They won't be able to take advantage of that M1. You're hiding that. You're enforcing client to only use your M1 rather than the base class's M1. This is another technique of making it like kind of protected. No one else can use it really. You're shadowing it. There's a keyword called MyBase. It refers to the immediate base class. Means no matter where you are, in what class, if you say MyBase, you automatically go to your own base class. Can only access public, protected, and friend members of the base class. And is not the real object. It's just a pointer. In this scenario, within your derived class, you can call MyBase and then call one of the functions from your base. You cannot use me keyword. You have to say MyBase. Also, you have myClass keyword. You can use that in order to ensure that the base class information of an overridable method is called. In this scenario, you have a base class has a couple of methods, one other and one overridable method. In this scenario, if you want to call a function from your own class, you have to call myClass. If you want to call a function from your base, you say MyBase dot whatever, or you can say MyClass dot whatever. Automatically shows all the information. For example, in here, if within the code, if I wanted to call from the drive class for the sake of discussion, from this say hi, I want to call that, I can say my class and automatically shows all available functions. Or you can say MyBase and I can get exposed to all available functions of MyBase. So these two keywords are already available for us. I've already shown you lots of examples of inheritance. Now let's discuss interfaces. We don't talk about interfaces in detail really because outside of the scope of this class, but usually in order to define an interface, you have to understand that an interface is just a contract. It's just a signature of what a class can have. It's not implementation. Interface is just a contract. For example, you specify how many methods, how many functions you have, what type do they have, what are the names, and that's it. How do you implement it? That's up to your class. In order to define an interface, you have to define it as a public procedure, property, or event. And then you use the interface keyword in order to declare that. You say interface. Usually the interfaces, they have a naming convention that starts with I, capital. And then you just declare the signature. As you see, you do not create the block. You just go ahead and declare signature of properties and methods and events and whatever you got. An interface defines a signature for procedures, properties, and events, but contains no implementation code. Even though you put implementation code, they will be ignored. So in order to declare an interface, all you have to do within your class, for example in here, I can call it a public class, a class, for example. I can say, obviously, this is my class, but before that, I'm going to use interface, call it an interface I Sohail, for example. Within this interface, I'm going to create a function, greet, and then I'm going to create additional sub, for example, hi, and sub, bye. You see, I say this is my interface called iSohail, and I have these three functions. By the time I want to create a class, I can inherit from that interface if I want to. I can actually achieve polymorphism using interfaces. For example, I have two different interfaces. Let's go with another interface. Interface, for example, interface apex. I can say function register, and that's it. Within the class, I can inherit from one or more interfaces if I want to. So in order to do this, all I have to do now within my class, I can go and choose a specific interface that I want to, obviously. But before that, I have to say implements. There's a new keyword called implements, and I'm implementing a specific interface. And that would be, for example, iApex. It's going to give me an error message because it says you have to really implement it. So if I go to iApex, automatically I can take advantage of that particular method. So in this scenario, if I wanted to take advantage of this, I can actually go to a class and say, this is my interface, available interface, and I can go and implement my register. Automatically goes and put the code appropriately for implementation of that class. Can I use implements more than one time? For example, if I go with Sohail, again, the same problem happens. If I go to Sohail, I can actually use by, use also greet. If you don't implement all functions, you're still going to have a problem. And finally, hi. Now you don't have any problem. So you can implement as many as interfaces as necessary, part of the class. So polymorphism, once again, allows many classes provide the same properties or methods. A caller doesn't need to know the type of classes based, which is based on this specific object. For the sake of discussion, right now, I have a class that I've implemented these things differently. For example, here, let's go put some message boxes. Message box by a class. I say greet a class. I'm just going to try to show you the concept of polymorphism. Hi, a class, and finally register. Register a class. Now, since this is a class, I'm using these two interfaces, and they have made it standard. If I go and create a second class, public, for example, another class, not to mention that I have to use the class keyword. Again, I have to say implements Apex and implements Sohail. Let's go ahead and do this again. Part of another class, I have to write the implementation. Select Sohail and then choose by, greet, and hi. So now within my VB code, hopefully I didn't do anything extraordinary. I meant to just, okay, I dragged the wrong location. Let's just go and bring up another form. Within this button, if I go and declare a variable, dim, for example, my A class as new, let's go with an A class, and then dim my B class as new, a B class. Let's see what's going on over here. My class is the what did I name it? Let's make sure that okay, this is public class, another class, and then public class, a class. Let's see if I have it anywhere else. Okay, that's good. I didn't have it anywhere else. Make sure that everything is good. Let's go with my classes dot a class, and then my classes dot I'm looking for B class. What did I call it? Another class, I call it, or something. Yeah, it is another class. Let's call it B class rather. Naming conflicts. Okay. Now as you see, if I go with my A class, I get by, of course I could use with this object, like Visual Basic does, say dot by, dot hi, dot greet, and dot register. I can repeat the same thing with a different class. Both of them are coming from the same interface, don't they? But definitely different implementation. So if I go and run this, you realize that first I'm going to run the A class and then I'm going to run the B class. And you realize the same function do a totally different thing. This is class by, hi, greet, register for A and then B. So I'm pretty much using the same interface. I enforce my classes to use exact same signature no matter what I do, but I have a different implementation of it. So the whole idea of having interfaces is to create a contract and a standard within software development. Then we have the shared data members. In Visual Basic 6.0, if you recall, you could share data among different objects using the module or a standard module. So you didn't have to specify the class dot property. You could just put it in a standard module, everybody could use it. Here in VB.NET, you could just use the shared property. That way you are sharing that particular object with all available classes. They don't have to refer to it by a class name. In this example, you have a class called saving accounts. You have a variable called interest rate, and interest rate is a shared property. So that interest rate can be used with other classes as well. So if you declare a data member as a public, they're accessible to any code that can access the class. If you declare the data member as a private, provide public shared property to access the private shared property is also another way of doing it. So in this scenario, the interest rate can be set before or after any instances of the saving account object. As you see in here, in the last section of this slide, saving accounts.interest rate, you're setting the value. So you're just treating it like a regular shared property object. You could also use the shared procedure member versus a property. You could just put the shared keyword right at the beginning of a procedure. That way you are sharing that procedure without declaring a class instance. It's very similar to global classes in VB 6.0. You can only access the shared data within, the shared procedure. Also, in regard to the event handling, the same way that we used to work with in VB6 is supported. However, there's a new concept, part of the event handling. They call it add handler. Defining and raising events is pretty much the same as VB6, but you also have a new keyword called add handler. In this scenario, by putting an add handler, you are specifying a particular event, and then you are passing that to a particular procedure. That way you are sharing the same code to be used for different controls or different procedures within your own class. If you recall, part of VB6, you also had a keyword called with events. You could use with events in VB.NET the same way that you use VB, in VB6. For example, on page 60, as you see, it says them with events X as test classes and them with events Y as test classes. That way you are creating a couple of instances of your object, and you wanted to expose the events capabilities of it. You could use add handler in order to create an event handler for yourself programmatically. I have a demonstration in which I'm going to show you. If I go ahead and add a new project, actually let's go ahead and add a existing project that we have taken care of it for you. Part of demo codes and part of module 5. Part of the handling events, if I go ahead and open up the events folder in here and trying to add this event project, make it a startup project. As you see, part of this form, we have already created it. The employee itself, we have with events, add handler, and so forth. This is the old technique, this is the new technique of doing it. Using the with events, I'm just using the name of the button underscore click, and using the new selection called add handler, we're actually using the add handler click events. Part of the employee object, as you see, I have a class called employee. I've created an event by calling public event keyword called data changed. I'm passing some arguments to it. And then I'm creating a few variables. I have a property, as you see in here. And then all I have to do within the read-only property or one of these methods, I'm automatically calling or raising the event appropriately. On the first name, as you see, I'm raising the event. Anytime the value changed, we are raising the event data changed. So, within the form, if I go to the with events, I'm setting the value, and by setting the value to the first name property, automatically I'm raising an event. So I have to handle it somehow. In order to test the project, let's just go ahead and run this. If I click on with events, see what's going to happen. It says, okay, the first name has changed, and then the last name has changed. If I go with an add handler, the same thing is going to happen. The only difference here is that you're using a new technology, which is adding a handler. In this scenario, as you see, we are creating a handler, which is the same function that is being called, say hello to the body. So in this scenario, I'm creating an event with event keywords in order to be able to expose the object. So that is the way that I'm going to create a new instance of that particular object in this scenario. Delegate is a new concept in VB.NET. Sometimes you want to have one function to go and take care of few things. You don't want to wait for that object. Delegate is one of the methods that you can create asynchronous programming. How many times has happened that you wanted to call someone, but that object is not available? You don't want to wait. You want to have someone to do the job on behalf of you and let you know when the job is done. So objects that call methods of other objects are delegates. They are similar to function pointers in C++. The only difference here is that they are pretty safe in regard to the type goes. Because function pointers in Visual C++, you never have a guarantee that you're going to go back to the same address that instantiated it. The reference type based on system.delegate class, so it's type safe and is secure and is managed. The example would be like a scenario that you want to have an intermediary call between the procedure and the procedure that is being called. The concept of a delegate is outside of the scope of this class, but we're just talking about it a little bit in here because .NET Framework requires us to talk about here a little bit. Delegate keyword declares a delegate and defines parameters. Methods must have the same function parameters and return type, and then you're using the invoke method in order to call the delegate. As you see in this example, on page 65, we have a simple test. We are declaring a instance of our compare function. The compare function was already defined as a delegate on page 64, if you take a look at it. Or as you see on this slide. It says delegate function. You just put the keyword called delegate function, compare function. That's the only thing it takes in order to create a delegate. You just put a delegate keyword. So it is a regular function anyways. But by putting that keyword, it acts like a delegate. And what is the delegate anyways? We are discussing it right now. So right now, this is a signature. You just put a delegate and that's it. And then by the time you want to use that, you just declare an instance of that delegate. And then you're passing a different address to it. In this scenario, you say compare ascending or compare descending. So your delegate might call different functions accordingly. In other words, like a dispatcher that calls different functions based on what you want. It's like a broker, it's like a butler, performs the job for you, and it might change it accordingly. How many times in VB6 you had more than one button, but all buttons, they had the same code? You had to copy paste it on every single one of them. Either you had to create a control array, or you had to create a function and you had to call that. This is very similar to that concept. They call it the delegate. There's an example on page 65 that says perform a bubble sort using a delegate. So that would be pretty handy for those kind of scenarios. In order to compare classes to structures, remember that the classes can define data members, properties, and methods. The structures can define data members, properties, and methods. So what's the difference between the two? Well, the classes support constructors and member initialization, but the structures, there is no default constructor for them. Classes, they have a destructor, which they call it the finalize, but the structures don't have it because they don't have a constructor. Classes are extensible, the structures are not. And classes are reference type, the structures are value types. So they spend less memory and less time. This section of the course pretty much concluded object-oriented programming. Again, this is huge object-oriented design and programming. It takes even further than these 2 chapters. So hope to hear from you soon, and